Hey guys, it's Miss Hazel. This week for week 5, we're going to actually start our circles unit, which will be the last unit for this entire school year. So yay. So we're going to go over some definitions and hopefully you've already done the vocab assignment. So we're going to start off reviewing what a central angle is. So a central angle is an angle with its vertex at the center of the circle. So we've dealt with central angles off and on pretty much all year long. Okay, so an arc, so a minor arc is less than 180 degrees. Okay, in a second I'll tell you how many letters you're going to use to name those. A semicircle is half of a circle. It's going to be equal to 180, and then a major arc is going to be greater than 180 degrees. It's going to be less than 360 though, because it's going to be a portion of the circle. Okay, so if we look at example number 1, the central angle, you're going to use 3 letters for that. Okay, so you've got AOB right there. That is your central angle. Remember, the O is the center of the circle, so you actually have to use that one in the middle. So that's why it's AOB. Okay, a minor arc, remember, is less than 180 degrees. So I'll color code here. A minor arc, okay, could be from A to B. Think minor, so smaller, and you're going to use 2 letters to name that. So an example of a minor arc in this diagram is arc. I'll write it out to the side. A, B. Okay, and you use that little arc symbol. One of the major arcs here is going to be a CB. So for a major arc, you're going to use 3 letters, and you're going to go through all 3 of those. Okay, the other way you could name this one is if you go backwards around B, go through C, and stop at A. But naming those in that order does matter. C has to be in the middle there, kind of like when we dealt with angles all year long. Okay, now just some important pieces of information if you want to write these down on your notes. The measure of a minor arc is equal to the measure of its central angle. Okay, the measure of a major arc is going to be 360 minus the measure of its associated minor arc, and that'll make more sense after we go through some examples. So, example 1 was just that vocabulary one. Example 2, okay, it says find the measure of arc AB. Okay, so arc AB is from here to here. It's that portion of the circle. Okay, you've got the central angle. You know this right here is the central angle, that 50 degrees. Okay, well, in this text box right here, it says that a minor arc is equal to the measure of its central angle. So since the central angle is 50 degrees, the minor arc is also 50 degrees. Okay, and next it says to find the measure of arc ACB. Arc ACB, okay, we're going to start at A, go through C, stop at B. So that's the arc ACB. To find that one, that's a major arc. We use 3 letters. It's 360 because that's the measure of the entire circle minus this portion of the minor arc that we already found to be 50 degrees. So 360 minus 50 is 310 degrees. Okay. Next example. So it says find the measure of arc ACB. So we're talking about a major arc here. So the arc ACB start at A, go through C, stop at B. Okay. That is going to be equal to 360 minus this portion here. Okay. So you would do 360 minus that 110 degrees because this right here is an arc, is the minor arc that is associated. Okay, so think of kind of like almost like a piece of the circle. So if the full thing is 360, make logical sense about it. If this piece is 110, you would just use subtraction. So you get 250 degrees. And then it says find the measure of angle AOB. So this time it wants you to find this measure of this central angle, okay? Well, we just went backwards over here. We said if the central angle is 50, then the minor arc is also 50. So you can also do the opposite of that. If the minor arc here is 110, then that central angle is also 110 degrees. So we actually knew that one to begin with, okay? Example 3. Okay, this one looks a little bit more complicated. If you want to draw this, it's a little bit hard to see, so I'll rewrite over it. This is 60 degrees, 82 degrees, and 100 degrees. So we're going to find 3 different arc measures here. Excuse me. So let's start with BD. So BD is a minor arc, okay? So it's from B to D. Now, that is a minor arc because that is less than half the circle, so it's going to be less than 180 degrees. If you went the opposite way, so if you went from B through E to D, that would have been a major arc, and you would have had to use 3 letters to name that. So just be careful there. Okay, so we know that this central angle, that's this portion of the circle and this portion of the circle. So we've got to find this entire central angle right here, and you have each piece. So 60 plus that 82 will give you 142 degrees. So the arc measure of BD is 142 degrees. Okay, let's move on to BED. So now we are talking about the major arc BED. So start at B, go through E, end at D. Okay, so now we have the other portion of the circle. Okay, so there's a couple different ways you could do this one. I'm going to do what I think is the most simple. You already know that this right here, okay, was 142. We know that the entire circle equals 360, so we need to do 360 minus that 142. Okay, when you do that, you get 118. I'm sorry, 218. So your answer here is the 218. And then that last one, it says arc measure BE. So you're looking at from B to E. So that's the only piece we actually don't know yet. So if the full circle is 360 and we have the other 3 central angles, then we can just do 360 minus the 60 minus the 82 minus the 100. Okay, so when you do that, you get 118. Okay, so that's it on the notes for central angles and those arc measures. Okay, so if you want to pause the video and take a break, you can. We're going to actually do 3 concepts here. So this next one is called circumscribed angles. Okay, so a circumscribed angle, I don't know why that switched colors, whatever, is an angle whose vertex is outside of the circle and whose sides are tangent to the circle. Okay, so this is going to be the major point right here. It's going to be outside of the circle. Okay, the measure of the circumscribed angle is half. Okay, is half of the difference of the intercepted arcs. Okay, so that's the formula in words. Okay, so we're going to actually see it as a formula here as well. So let's just go through some of the vocabulary with this image. This is an A, if you can't read it, guys, this is an A, B, and C. Okay, so angle 1 here is your circumscribed angle. And remember, that just means that it's outside, okay, of the circle, and the sides are tangent to the circle. Okay, so I'm not going to touch on that as much, but just remember it's the one that's outside of it and it forms that angle. Okay, so the it says the measure of that is equal to half of the measure of arc BC. So arc BC in this case is our minor arc. Okay, and then there is also another minor arc called AC. Okay, remember this is the intercepted arc. Okay, so arc BC is the intercepted arc. And that's because it's enclosed from that angle. So if I were to go over here and I'll trace this circumscribed angle 1, okay, because from B to C is enclosed between there, that is called the intercepted arc. Okay, so you take the bigger one here minus the smaller one and then half that. So let's do an example. So you're going to find the measure of angle 2. So angle 2 is our new vocabulary term, the circumscribed angle, because the vertex is outside. So the vertex is here. So this right here is your circumscribed angle. Okay, so to find angle 2, we're going to use this formula we just figured out. Okay, so let's say, I'm going to give you some numbers here, guys, since it doesn't have any labeled. Let's say arc PQR. So this time arc PQR is our intercepted arc. Let's say that's 210 degrees. And let's say that our minor arc PR is equal to, let's see, if that's 210, this would be 150. So to be able to find angle 2 right here, we actually need to subtract. So I'm going to subtract 210 minus 150, and then I take half of that or divide by 2. And that's exactly what is up here in this formula and in this definition. Okay, so 210 minus 150 is 60 degrees, and then we need to take half of that. And that's just a new rule that you need to either write down, memorize. Since we're on NTI, you can actually just write it down and use your notes if you need to. That's fine. Okay, example 2. You've got to find another circumscribed angle. This time it's angle 3. It's circumscribed because the vertex is on the outside. And it actually tells you you're going to do the arc XY. This is a Y, guys. This is a W if you can't see it. This is a Z. Let's go back to this. The measure of XY minus the measure of YZ. Okay, and then you'll take half of that. So same idea. So let's give you some numbers. Let's say this one, let's say arc XY is 100 degrees. Let's say WZ is 40 degrees. So to find angle 3, you would do 100 minus 40, take half of that or divide by 2. And I did not mean to make this one be the same answer as the last one, but that's okay. All right, so this one actually is already labeled for us. So it says solve for x. So x is our circumscribed angle because the vertex is on the outside and these two rays form that angle and go through the circle. Okay, so I just need to do this time I'm going to actually write out our formula. I need to take half of the difference of the two arcs. So I'll take half of arc PR minus the measure, that should be a measure of, measure of arc QS. Okay, so if you like to just kind of fill in for the formulas, you do this one minus this one and take half of that. So 115 minus 25. Take half of it or divide by 2. Remember, that's the same operation. When you do that, you get 90. Divide that by 2, and you get 45 degrees. Okay. If you feel like you're ready to go and want to try this one on your own, go ahead and pause the video. And then when you're ready to check your answer, unpause, and you can see the worked out solution. So this one will be arc EG minus arc ED. Okay. So we've got 175 minus 35 equals, that is 40, and then divide by 2, so you get 20. Sorry guys, I did not do that math right. So that should be 175 minus that 35 is 140. My bad. And so you get 70. Okay, so you get 70 degrees for that circumscribed angle. All right, example 5. Same idea. You're going to take this larger one minus this inside one, if you will. So angle 1 will be equal to 220 minus the 140. Divide that by 2. So 220 minus 140 divided by 2, you should get 40. You should get 80 divided by 2, so you've got 40 degrees. And that is all for circumscribed angles. So we've got one more type of angle to learn how to solve for. Those are called inscribed angles. Okay, so an inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of the circle. So you should remember what a chord is from your last video or your vocabulary assignment. Okay, and then an intercepted arc, which we talked about in this video already, is the arc between the two sides of the inscribed angle. Okay, so in this first example, we're literally just going to go ahead and name some things. So name the inscribed angle and the intercepted arc. So remember, the inscribed angle is the vertex is on the circle. So this is our vertex of that angle. So it's on the circle. Remember how to name an angle. Use those 3 letters. B does have to be in the middle. Okay, so angle ABC is the inscribed angle. You could also go the other way and say CBA. So, or angle CBA. And that's just how to name them, guys. That's it. Okay, the intercepted arc is the one that is between the two sides of the inscribed angle. So this portion of the circle right here is an arc. That's the intercepted arc because it's between this A and this C. Okay, it's between the two sides of the inscribed angle. So the intercepted arc in this example is not equal to, I'm sorry, I'm just naming it right now, is AC, arc AC, okay? Okay, the new rule here is the measure of the inscribed angle is going to be half of the measure of the intercepted arc, okay? So you're just going to take half of that intercepted arc. Now, you may have to use some other circle properties that we've learned, okay? But we're going to start simple. So it says the measure of arc AC So this is the arc AC right here. That measure is 120 degrees. And I want you to find the measure of angle ABC. ABC is the inscribed angle. Remember, don't get inscribed and circumscribed confused. Inscribed is where, think inside the circle. So the vertex is on the circle. Okay, so remember, if you need to reference that vocabulary term up top, you can. Or in the beginning of this section of the video. Okay, so you've got 120. It says the measure of the inscribed angle is half of the measure of the intercepted arc. So if the intercepted arc is 120, then the inscribed is 60. So you just divide that by 2, so you get 60 degrees. Okay. Example 3. So the measure of arc AC, so same circle, I just copy and pasted, just change the numbers, is 142 degrees. Okay. It wants the angle measure for angle ABC, which is an inscribed circle. Okay. Since AC is the intercepted arc, we can just take half of that, and half of 42, 142, is 71. Okay. Example 4. Almost done, guys. So example 4, it says the measure of angle ABC is 100. So you got to be really careful. This time it's going the opposite direction. So we're starting with the inscribed angle. So I know that this angle right here is going to be 100 degrees. Okay. It wants you to find the measure of angle or arc ADC. So arc ADC, okay, start at A, go through D, stop at C. That's a major arc because it's greater than 180 degrees. It's going to be the opposite. So if we had this one, we would have taken half of that and got 100 for the inscribed angle. So the opposite of taking half is doubling. So 100 times 2 is 200 degrees. And then example 5, last one. This one does apply a couple other concepts. So let's talk through this. Don't lose me. Okay, so you've got ABC is 70 degrees. So again, they're giving you the inscribed angle this time. And it wants you to find the arc measure of ABC. So I always recommend you to actually trace over those and don't just go through the process. So go through B, start at A, go through B, and at C. Now, that is not the intercepted arc. The intercepted arc is the minor arc AC. Okay, so you've got to be careful there. So we can go ahead and find arc AC. It's double the 70. So it's 140 degrees. And now that you only have the major arc ABC left over, you just need to do 360 minus the 140. And that will give you 220 degrees. All right, guys, that's it. You make sure you get on Google Classroom after this and go ahead and work on those assignments. And if you have any questions, please let us know. Show up at our Google Meets and have a good day or night whenever you're watching this.